Hello everyone, you're most welcome to this YouTube video tutorial. My name is Atong Abraham, a student of Makerere University. We're going to look at data cleaning and exploratory data analysis. So, exploratory data analysis is a vital part of data science as it aims to discover relationship between the entities of the data we are working on. Here, under overviews, we're going to look at heat maps, correlation matrices, box plot, feature independence plots, outlier plots, illustration of pattern of interest, illustration of trends, in time and space, display data into trend validation and test sets, fit anyone, fitting of the module, and hyperparameters, variation of validation sets. Now, data cleaning is removing the null values, inconsistent values, and also the relevant columns. We previously had this kind of a table, and when we did data cleaning, this the table obtains where we have three kind of columns with the names modified, no null values, and then we also don't have missing values. Now, Heat maps. Heat maps is a graphical representation of data where values are depicted by colors. So when we do the heat map, we're going to have this kind of we are going to have this kind of graph. This is having average temperature, confidence interval. This is the coefficient values given on the left hand side. Let's look at correlation matrix. Correlation matrix is a table which displays the correlation coefficients for different variables. Now, the correlation matrix gives the correlation values where we have average temperature confidence interval. This one means the relations is very poor. Then we have the negative. Then we also have the negative coefficients value, which shows the relation, which shows also the four negative relations. Outliers plots. An outlier is an observation that lies on an abnormal distance from other values in a random sample of data. So we're going to have two graphical techniques, the scattered plots and the box plot. When we consider the first case, the scattered plot, the box plot, we're going to have this kind of a graph. Now, the values which are lying above 14, these are the ones called outlier. These are outliers actually. And when we consider for the case of a scattered plot, we're going to see that some values are spreading away from other values, and these ones which are at extremely far from other values are the ones called outliers. Splitting data into train, validation, and test sets. Now we are going to look at train data sets, valid data set, test data sets. Now when we first consider the first scenario, which is train data sets, we're saying that set of data used for learning or for module learning. Then the valid data sets is the one is set of data used to provide an unbiased evaluation of model fitted on the training data sets while turning model hyperparameters. And then the test data sets were a set of data used to provide an unbiased evaluation of the final model fitted on the training data sets. There are two techniques that we can use: is splitting randomly, splitting using the temporal component. Here we are going to illustrate only that is splitting randomly. So when we go through this kind of algorithms, we are going to have outputs like for the train data, then outputs for the validation data, then also for the testing data. Now, clearly we are seeing that the validation data outputs is matching the testing data outputs. And here in our algorithms, we're saying 50% of the remaining data is the one shared by the validation and the testing data sets, whereas the remaining is to be used by the training for training the model. And that is all about data splitting. Future independence plots. This displays like the y-axis to be having the dependent variables, then the x-axis with the independent variables. So when we do the plotting for the two variables, we are going to have breast temperature on the y-axis, then the confidence interval on the left axis. Illustration of trends in time and space. Now, this is the movement of a series to relatively higher or lower values over a long period of time. So we are having a graph where the blue color represents the average temperature, and then the red color represents confidence interval. That is trends in time and space. Hyperparameter turnings. Hyperparameter turnings is the process of determining the right combination of hyperparameters that maximizes the module performance. So it works by running multiple trials in a single training module. Now, we can have this kind of methods like random size, grid size, variances, optimizations, but basing on the random size, basing on the random size, so the algorithms we use here is going to give us the output where we have the penalty and then the C. So best penalty is going to be 12, then the best C is going to be 3.745 and so on like that. So this is basically about hyperparameter tuning. Model fitting. Model fitting is a measure of how well a machine learning model generalizes to similar data to that on which it was trained. So based on these three categories, well-fitted, overfitted, and underfitted. So we say that well-fitted produces like more accurate outcomes. Overfitted matches the data too closely, then underfitted does not match closely enough. So and when we did the model fitting, so this kind of the graph where we have the line of the best fit was in the middle. Now, evaluating the validation sets, when we evaluate the validation sets, actually we are performing the model training, which is evaluated like the testing data sets. So we here going to have mean square error, then calculating mean square error by hand. So at first the mean square error, we're going to obtain this kind of value, and then calculating by hand, then we also obtain this kind of value. And that is how validation is done. And thank you for listening this end of our video. Subscribe to my YouTube channel.